So here's our example. Students pull a water balloon back in a water balloon launcher. Then they release it. The launcher applies a force of 60 newtons to the 0.5 kilogram water balloon for 0.4 seconds. So what we want to do is we want to figure out first the impulse on the water balloon. Okay, and it tells us we have to show our work by writing the equation that we use without any numbers in it, and then we have to write the math that we're going to do, and then we're going to write the answer with the units also. So this right here, that's what I just read right there. Okay, that's all the things that we have to write down. We're going to get some points for all of those pieces in our answer that we write down. Okay, so the equation that we're going to need to use is the one that's going to give us the impulse, right? Because the impulse is what we're being asked to find. Impulse right there. So I'm going to start by writing down the equation that gives me impulse. It's right up there. Okay, so there it is. Impulse equals force times time. And it tells me that the force is 60 newtons, and I've got a whole bunch of numbers there, but it says 4.4 seconds. Seconds is the thing that measures time, so that's what I'm going to use to figure out what the number is. So I'm going to use that 0.4 right there. So that's what I'm going to write down right here, and I'm going to be multiplying, so I put a little dot there. Now remember, this plus is just a direction. It's a positive number, so I'm pushing, the water balloon is pushing in the positive direction. The launcher is pushing in the positive direction. So I don't have to add anything there. It's just going in the positive direction, okay? So now I'm just going to plug that into my calculator, 60 times 0.4, and my calculator tells me that it's 24 Newton seconds. I kept the positive because that's the direction. Impulse has direction, okay? And so it's in the same direction as the force, which is in the positive direction. So the impulse on my water balloon is in the positive direction, and it's 24 Newton seconds. That's what that tells me. And if you wrote all that stuff down too, you would get all 4 points on the test, okay? Now, the initial momentum of the water balloon is what it wants me to find next. You'll notice that it says show work if necessary, okay? Show work if necessary. So that means that on this one, I can probably think about the answer without actually writing a whole lot down, but I'm going to write some stuff down as I think about this, okay? Because, that's how I think about stuff. Okay, so it says, what is the initial momentum? Okay, so I got to think about what the water balloon is doing. Okay, so I'm a kid. I got a water balloon launcher. I'm going to pull it back and stick a water balloon in it, and then I'm going to let go. Okay, so in the beginning, what is the water balloon doing? Well, it's just sitting there. It's at rest, which is 0. How much momentum does something have when it's at rest? Oh, it doesn't have any. Okay, so it's 0 kilogram meters per second. Okay, that's why I didn't really have to show any work. Okay, show work if necessary means I can probably think about it. Now, if you want to write down P equals M times V and put the M in there and then put the V in there and then write down P equals 0 kilogram meters per second, you go right ahead. You can do that too, okay? Now this next one says show work if necessary also, which means I might be able to think through or I might need to write something down also, okay? And so I'm going to do the same kind of thing. It says what is the final momentum of the water balloon? Okay, so let's think about this. So it started with no momentum, and impulse changes the momentum. So that impulse must have given it all of the momentum it has. That's kind of the thinking that we need to go through here. Impulse equals the change in momentum, okay? And I think all I did was I wrote down the answer here. So the final momentum must be that 24. It didn't have any to begin with, okay? So it must be going from 0 to that 24. Now, again, if you need to write more than this down in order to get to the answer, then you go right ahead, okay? If you are capable of only writing the answer down, in this situation, only the answer would still get you the credit, okay? On this last question, it says find the final velocity. Final velocity is what it's asking for now. But now I have to show all my work. It says write an equation, show the math and the answer. So this time I'm going to need to use an equation to do this, okay? And if I want to find the velocity, this equation right here is the only one I have with velocity in it. Well, it says velocity equals, okay? And so that's what I'm going to use. And I'm finding the final velocity, so I should probably use the final momentum, okay? Hint, hint. So The final momentum is 24, so that's what I'm going to plug in along with the mass, which was given in the beginning of the question, which is right there. Whoops. Right there. Okay. So 24 kilogram meters per second divided by 0.5 kilograms. Okay, I want to plug that into my calculator. I get 48 meters per second. That is a swiftly moving water balloon, to be completely honest, because that's like almost 80 miles an hour. Actually, it might be more than 80 miles an hour. I forget which. Either way, that water balloon is booking it, okay, and it's going to smash into something or maybe go really high and then come back down. Either way, it's going to pop, get something wet, okay? So there's a bunch of examples, problems in the practice for you to do where you'll have to think through. Each problem individually has these kind of parts in it where you will have to go through some steps and think through what is going to be the final result, okay? And so that's it. Make sure you ask for help on these if you need it. They're sometimes kind of tricky to think through, okay? And drawing pictures are so useful in this situation. Drawing a picture can really help you out, especially if you make like a before and a during. Hang on, let me write that better, you know, with an actual pen you can read and not this giant thing here. So if you make like a before picture and write down what you know, and then you make like a picture of like during, so like the actual impulse and what's changing in the force and how long that takes. And then you make some after pictures of like the momentum that's after. That can help you really organize the information so that you understand what's happening and you use the right pieces of information to make your calculations. Okay, thanks for watching.